Question 27, Part C. Sanjeev starts saving for a holiday that he wants to take when he finishes his TAFE course. He decides to invest $200 per month at the end of each month by placing it into an account earning 6% per annum compounded monthly. He will do this for 4 years. Will Sanjeev reach his goal of $10,500? By how much will he fall short of or exceed his goal? We can model this situation using a recurrence relation and then the sum of a geometric series to determine the value of Sanjeev's investment after 4 years. Let AN be the value of the investment at the end of the nth month. Now the interest rate per period is given by 6% per annum or per year divided by the number of compounding periods in the year. Now it's compounded monthly and there are 12 months in the year. So 6% per annum divided by 12 is equal to 0.5% per month. And the number of compounding periods is given by 4 years multiplied by the number of compounding periods in a year. So there are 12 compounding periods in a year. So 4 times 12 equals 48. The value of the investment at the end of the first month, A1, is equal to $200, as it earns no interest since it's deposited at the end of the month, not at the beginning of the month. Now the value of the investment at the end of the second month, A2, is equal to the value of the investment at the end of the first month, A1, increased by 0.5%, and that's done by multiplying A1 by 1.005 and then adding on another $200, which represents the amount deposited at the end of the second month. Now A1 is 200, so substituting 200 for A1, we get A2 is equal to 200 times 1.005 plus 200. Notice that this is not evaluated. It's left in this form for good reason. And that's so that eventually we can generalize an expression for AN. Now the value of the investment at the end of the third month, A3, is equal to A2 times 1.005 plus 200. Again, for the same reasons as A2. So we're just increasing A2 by 0.5% and then adding on another $200 at the end of the third month. Now A2 is 200 times 1.005 plus 200. So substituting this expression here for A2, we get A3 is equal to 200 times 1.005 plus 200 in brackets times 1.005 plus 200. Expanding the brackets, we get A3 is equal to 200 times 1.005 squared plus 200 times 1.005 plus 200. Finally, factorizing out 200 from here, here, and here, we get A3 is equal to 200 multiplied by 1 plus 1.005 plus 1.005 squared in brackets. Next, we generalize a pattern for AN, which represents the value of the investment at the end of the nth month. So notice from A3, we get A3 is equal to 200 multiplied by 1 plus 1.005 plus 1.005 to the power of 2. So this value here is 1 less than this value here. So if it was A4, the power here would be 3. If this was A10, the power here would be 9, and so on. So generalizing the pattern for AN, we get AN is equal to 200 times 1 plus 1.005 plus 1.005 squared plus plus 1.005 to the power of 1 less than n, which is n minus 1. Notice that what we have in brackets is a geometric series with the first term 1 and a common ratio r of 1.005. So we can replace what's in brackets here with the sum of a geometric series formula using the values for a and r that we just found. So an is equal to 200 times 1 minus 1.005 to the power of n, since there are n terms in this series, over 1 minus 1.005 in brackets. Next, we evaluate A48, which is the value of Sanjeev's investment at the end of the 48th month or the end of 4 years. So that equals 200 times 1 minus 1.005 to the power of 48 over 1 minus 1.005, which equals 10,819.56644. So the value of Sanjeev's investment at the end of 4 years is $10,819.57, correct to the nearest cent, which is greater than his goal of $10,500 by $319.57.